Alright everyone, so now we have reached the final question for the examples from our subtopic derivative of exponential function. The question asks us to find the second derivative of this function here. So you can see that the variable in this function is theta, and the function is y equal to 5e to the power of theta minus 2 over 7 cot theta. So first of all, let us rearrange first the question here. So your y now is equal to 5e to the power of theta minus 2 over 7 as the constant. And then cot here is cotangent theta to the power of negative 1. So I hope you can see clearly that this is involving chain rule because you have a function inside another function. So now let us straight away differentiate this. The first derivative is dy over d theta. So let's differentiate the first term. 5 times e to the power of theta is equal to 5 e to the power of theta. Then let's find the derivative of the second term. So for the second term, let's focus on the outside function first. Okay, this is ayam to the power of negative 1. So let's find the derivative of that first. Ayam to the power of negative 1 is just bring down the power reduced by 1. So this will becomes minus 2 over 7. And then bring down the power. And then power here reduced by 1. And then let's further differentiate your cot theta. So when you want to further differentiate cot theta, further differentiating cot theta is this one here, minus cosecant squared theta. So let's write it, minus cosecant squared theta. So now we have finished differentiating this. Let us simplify this part here a little bit. So now let us simplify the second part here. For the constant, negative times negative times negative, this is just negative. And then for your numerator, you'll have 2 cosecant squared theta. And for your denominator now, you will have 7. And then here is cotangent squared. So let's write here, cotangent squared theta. Now, I want you to focus on this term here. We can simplify this, all right? Let us do this. This is equal to 1 over sine squared theta over cos squared theta over sine squared theta. Okay, because secant squared is 1 over sine squared, cotangent squared is cos squared over sine squared. Now, let us simplify this. This is common term, you can cancel out. So you are left with 1 over cos squared theta. So what is 1 over cos squared theta? This is just secant squared theta. So this is the same with secant theta squared. So let us substitute this value here because we have simplified. Therefore, our new dy over d theta is 5e to the power of theta minus 2 over 7 secant theta squared. So now, after we have found dy over d theta, let us proceed to find d squared y over d theta squared. Let's further differentiate this function. So for derivative of 5e to the power of theta, this is just 5e to the power of theta. And then for this one here, I hope it is clear to you that this is a chain rule. Okay, because you have one function inside another function. This is ayam squared. Okay, so let's solve the outside function first, ayam squared. So this is minus 2 over 7 as your constant. And then let's differentiate this. Okay, so ayam squared is equal to 2 ayam. And we need to further differentiate ayam. Further differentiate inside function. So let's focus on our formula just now. Derivative of secant x is secant x tangent x. So let's do this. Further differentiate secant theta is secant theta tangent theta. So now let us focus on this term here because we want to simplify this answer. Therefore, the first term is just 5e to the power of theta. And then let's focus on simplifying this. So let's see the constant first. Minus 2 over 7 times 2. This is minus 4 over 7. And then secant times secant is secant squared. And then you have another tangent here, so just multiply it by tangent theta. Therefore, this is your final answer for double derivative. Let me recap back this example. You have this function here. So I have rewrite this function. So I bring up this one to become cot theta to the power of -1. So of course, this is chain rule. So let's find the derivative. The first term is just 5e to the power of theta. And for this one here, let's do the outside function first. Bring down the power reduced by 1. Further derivative. So this is minus cosecant squared theta. And then this is a simplified version. Further simplify this as secant squared theta. And we can substitute this here. Then let's find the second derivative. Let's further differentiate this. So the first term is just like this. The second term, again, this is chain rule. So bring down the power reduced by 1. And then further differentiate secant theta, which is secant theta, tangent theta. And then let's simplify this to get this answer here. So that's all for derivative of exponential function. Assalamualaikum warahmatullahi wabarakatuh.